Hi everyone! We are from Group RS 1201E. We would like to share what we have learned for Chemistry 121 subject.
There are many topics for the subject, but today I just want to point one chapter only, which is chapter 1. The title is Atom, Molecule, Ion and Chemical Equation. So, what are our content that we will discuss today?
We will discuss a few subtopics from the chapter 1, only 3 of them, which is definition, the mole concept, and Avogadro numbers, and also empirical number and molecular formula.
Okay, let's get into our first subtopic for the chapter 1, which is definition. Definition that I would like to explain is the term that are regularly used in chemistry subject. The first one is atom. Atom is the smallest unit of matter that retains an element chemical identity, consists of a nucleus, proton and neutron, and orbiting electron. Number 2 is proton, a subatomic particle with a positive charge found in the nucleus of an atom. Its number determines the element. Number 3 is electron, a subatomic particle with a negative charge, orbit the nucleus in shell or orbital, involved in chemical bonding. Number 4 is nucleon, the total number of proton and neutron in an atomic nucleus. Also known as the mass number, is represent the atom mass. Number 5 is element, a pure substance consisting of only one type of atom, defined by its atomic number, number of protons, and listed on the periodic table.
Next, isotopes. Isotope is atom with identical atomic numbers but different mass numbers. Most elements have 2 or more isotopes. Then molecules. Molecules form from chemical combinations of atom. They are combined in specific ratios to one another. Compound. A compound is a substance composed of atoms of 2 or more elements chemically united in fixed proportion. The last one is ions. Ion is an atom or group of atoms that has a net positive or negative charge.
Binary compound, metal and non-metal. Name the first element of the compound, the metal, by its actual name. The second element is then named by using the base of the non-metal's name and adding IDA suffix. Binary compound, transition metal and non-metal. Name the first element of the compound, the metal, by its actual name, including oxidation number by putting open bracket and close bracket for the name. The second element is then named by using the base of the non-metal's name and adding IDA suffix. Binary compound, non-metal and non-metal. Name the first element, which is element to the left side of the periodic table. Name the second element by adding it with IDE. And also, Greek prefixes are used to tell of how many H of the first element present in a compound. If there is only one of the first element, the prefix mono is omitted. The prefixes are mono 1, di 2, tri 3, tetra 4, pentra 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10.
Positive charge species on left, using stock methods name. Other that, negative charge species on right, using name of polyatomic ion. Hydrated are compound that have a specific number of water molecules attached to them. After that, number of water molecules show after a dot and is named by a Greek numbering prefix before the word hydrate. Next, hydro plus halogen names plus IC. After that, acids which do not contain oxygen are named of the element. Although acid is an acid that contain hydrogen, oxygen and another elements. Acids which do not contain oxygen are named by adding the hydro prefix to the root name of the element. Objective of this subtopic is determine atomic mass and relative molecular mass, percent composition, empirical formula, formula of compound, limited reactant, and after that perform balances the chemical equation and chemical stoichiometry.
So let's continue to our other subtopic, the Mole concept of Avogadro numbers. So relative atomic mass, or we call it RAM, is the weight average of all the naturally occurring isotopes of the elements. So this is the periodic table of the elements. We can see the difference between relative atomic mass and atomic number. Okay, next we continue with the other slides. The table shows the mass numbers and abundance of naturally occurring copper isotopes. So the table gives us mass number and abundance. For the mass number, we got the 60 and 65, and the abundance is 69% and 31%. We have to find the relative atomic mass of copper. For this question, we have to use formula of RAM, relative atomic mass. We have to find relative atomic mass of the copper. So we use 60 multiply with 69% plus with 65 multiplied with 31%. Then we divide it and we will get 61.55 am. So we continue to other slides about mole concept. So we will look at the triangle method. If we want to find mass, we can do moles multiply with RAM or RAM. If we want to find moles, we can use mass divide by RAM or RAM. It also same for the number of atom, molecule ion and Avogadro. So let's continue to other slide. Helium is a valuable gas used in industry. How many moles of helium atoms are in 6.46 gram of helium? We will use the formula. M will given is 6.46 gram. Molar mass is 4. So we use the mass divide with molar mass and we will get 6.650 mole. The second question is how many grams of CH2Cl2 are obtained in 2.88 moles of CH2Cl2. We will use the same formula. First, we find molar mass of CH2Cl2. 1 multiply with 12 plus with 2 multiply with 1 plus with 2 multiply with 35.5. So we will get 85 gmoles. After that, we multiply it. 2.88 multiply with 85, we will get 244.8 grams. So we go to other subtopic, the molecular formula. As we know, empirical formula is the simplest possible whole number ratios of all the atoms in a compound, while molecular formula is the formula which shows the exact number of atoms of each element in the molecule. The last one is, we will answer this question. So the question asks us to find molecular formula. So the molecular weight is given 318.31 gmol. So we divide the element to 3, carbon, hydrogen and oxygen. And the mass also has given for the carbon, hydrogen and oxygen. Then the mass, we will calculate the numbers of mole. The mass given, we divide with molar mass. As example, for carbon, we divide the mass with molar mass for carbon is 12. Then we will get the answer. After that, we calculate the smallest ratio and we will get the empirical formula. Then the empirical formula, we multiply it with 2. Then the final answer is
carbon 10, H7 and O2. After that, we will calculate the empirical formula. For the empirical formula, we use the C10H7O2 and we equal to molecular weight 318.31. Then we calculate it and we get the N equal to 2.